Well, one of the most popular, I think, arguments for the existence of God is kind of within this family of arguments called cosmological arguments, which look to the universe, the cosmos, at trying to show either a first cause or, a prime mover or something like that to show that something had to start this whole process. And so today we're going to be talking about one of those arguments, specifically the kalam cosmological argument for God's existence, which comes from out of this chapter. This is part 2 of our Apologetics series, walking through this book on natural theology, edited by William Lane Craig and J.P. Moreland. Chapter 3 is the chapter, from William Lane Craig and his co-author, and joining me today, James Sinclair, discussing the kalam cosmological argument. It's a very simple argument that simply says, everything that begins to exist has a cause. Premise 2, the universe began to exist. Therefore, the conclusion is that our universe had a cause. And so this show specifically is going to focus on premise 2 of that argument, looking at the scientific evidence for the beginning of the universe, then trying to show some implications of that if our universe really did have a beginning, and the science is really positively pointing in that direction, and everything that begins to exist has causes, then our universe has a cause, and what could have caused our universe. So that is going to be the fun conversation that we have today. As always, I want to open this up for you to post your questions and your comments in the live chat, and I will see about kind of incorporating them into the show. But my name is Ryan, and this is the show Think Well, the show that is created to help you think well about the Christian faith and about the culture so that you can respond well in having conversations about God and science, with this show focusing on that topic. Joining me is James Sinclair. He has a master's in physics from Texas A&M University and is a senior anti-air warfare analyst for the United States Navy, with his specialty in the construction of digital modeling of air-to-air combat. Now, you might say, okay, what does that have to do with this topic? Well, back in the early 2000s, and we'll hear that story in a moment, about 25 or so years ago, he began to dive into the topic of the beginning of the universe, and he started investigating and interviewing cosmologists on this topic, and then he brought in his Navy knowledge and integration methods into the formulation known as what we're talking about today, the kalam cosmological argument. So he has co-authored not only this chapter in this book with William Lane Craig, he's written another article on the non-singular spacetimes in the beginning of the universe with William Lane Craig, and co-authored some other journal articles. And so, James Sinclair, thank you so much for joining me for this conversation.
I'm pleased to be here with you today. Thank you for inviting me.
Absolutely. It took me a while, but I think one of the things I heard William Lane Craig talk about with this book is that each chapter was given to the author and say, take as much space as you need to make the best defense for your argument that you can make. And the kalam cosmological argument chapter came in at roughly about 100 pages of small print, for which you had a large portion on the cosmological evidence. So thank you for the work that you've done here, as well as other things that you publish on this topic, and for joining me to break it down for those of us who are not scientists and are not well studied in this, to make sense of how the universe's beginning points to God. We need smart people like you and others to do this for us, and so I appreciate that. So I want to jump in here quickly at the beginning, because again, your bio, so you're working full time with the Navy, doing warfare analyst stuff, but you kind of started this journey 25 years ago into the cosmological evidence for the beginning of the universe. So kind of, can you walk us through a little bit of your story? What brought you into this topic? What interested you in this argument, and kind of what was that journey like for you?
Well, I was raised a Christian, and but my journey it's like a lot of people, and especially when you have I'm an INTJ, Myers-Briggs. There are some people that just question and question, and you continually question, and it's part of your very nature. I'm one of those types. And so as I'm the classic person that, you go off to college and you wonder if your faith can survive questioning and objections. And in the late 80s, early 90s, it didn't look to me like there were very strong responses on the Christian side. So I didn't go to an agnostic phase in the sense that I became an agnostic. But I went to a phase where, call it a waiting phase, like waiting for more data, waiting for more information. And my faith suffered as a result. And then toward the late 90s, I came in contact with some good people here at the base that I work at, and they showed me some of the works of Hugh Ross from Reasons to Believe, especially Creator in the Cosmos. So I started reading on this, and I became acquainted with William Lane Craig as well. And I said, you know what? It looks like faith is defensible to me. It looks like maybe there's a better case for this than I had previously thought. And I went after it ultimately with all the energy of a convert, and just I was ravenous. I tried to get all of the material that there was, and to the level that in the late '90s, the Reasons to Believe, the ministry that still exists, it's out there. They had a radio show, and I called into the radio show, and the discussion was about Stephen Hawking's model, which we may get to later, his quantum gravity model of the universe. And Hugh Ross had made some comment at the time that suggests a beginning, and I had some questions about that. I said, well, how deep does this go, really? And I ended up from that conversation with him is, you know what? I kind of have the tools to do this myself. Maybe I can make a contribution. Maybe I can go a little bit farther. Back when I was at university, I was studying supersymmetry at A&M. Remember, there was supposed to be something called the superconducting super collider at that time, which got canceled. But the Texas A&M was going to be the center of the world on particle physics in that, even though that didn't pan out. But I became interested in cosmology at that time, so I started reading the papers. I could get some of the papers directly through the Navy had some subscriptions to journals that I could get to, but also the ARXIV website, the preprint website. You can read the beginning versions of most of these science papers online for free. So this is the internet. Oh, the internet becomes available, and then suddenly the cost of having access to the conversation was way down. So I made use of that. I made so that's so you're making a late use of the internet. I made an early use of it. And usually back then, and this is kind of still true today, usually a cosmologist will have email address on the paper. And so I started conversing with them. And a lot of them were Christians and still are, by the way. A lot aren't. The academy will tend to trend against for reasons that we can get into or not get into. And so I started developing a corpus of knowledge for these models. And just about this time when I was reading William Lane Craig, somehow I can't remember exactly how this happened. I was able to contact him through the Atlanta chapter of Reasons to Believe. And I said, you had said something about the ekpyrotic model, which is a string quantum gravity model, that I don't think is right. And let me help you. Here's what from talking to Paul Steinhardt, this is what I think is true. And that is what started our collaboration. He said, wow, there's someone out there who isn't hostile. He's actually helpful. And so, yeah, you say that I use my Navy methods. What does that mean? Well, when you're building a model like I do, a combat model, you're never the smartest person in the room. There's 4,000 things that have to go into that model, and you've got to go interview all the experts, and you have to learn exactly how much of that particular subject you need in order to put into your simulation, and no more. Because you can't be the expert in 4,000 subjects. We have those 4,000. So you have to get good at interviewing people and identifying what the important things are. And that's what I attempted to do with these various papers, focusing on the issue, the which ultimately became the kalam argument and the significance of the beginning. And what is it? What does the recent history of cosmology actually say about this? Is it trending toward the direction of a beginning or against? And that's what led to our work together. William Lane Craig suggested we write this particular article, and you've seen the result. It was published in '09, I think. Is that when the first article came out, or was?
I actually forget when this was. I can look at the page here really quickly. 2012, the first edition. I guess the hardback. The hardback in 2009. It says this first edition in 2012. So, absolutely.
Yeah, we've published a few follow-on articles since then.
Yeah. Well, that's great. Now, I'm kind of curious, as you survey the literature, one of the comments came in that the vast majority, or maybe a lot of cosmologists, believe in an eternal universe. It says the majority of cosmologists believe that the universe is eternal. Do you have any kind of idea, as you were surveying the literature? I'm not saying you can speak for all cosmologists, but did you find that is kind of the general view? Kind of like maybe when Christians approach evolution, it's like, well, yeah, the majority of scientists hold to evolution, but that doesn't make it right. But we have to recognize that's true. Or would you say, no, there's actually a significant number of cosmologists that hold to a past finite universe?
You're asking me if I agree with that it is.
No, I'm saying in your survey of the literature, do you find that the majority hold to an eternal universe, or is there a large number that hold to a finite universe?
I think that I don't think it's a majority. I think that there's a lot that do, but the sexy work is in finding the exception. I mean, a lot of that has to do with, okay, so some singularity theorem comes out. You say, oh, looks like you can't do this. The exciting place to do the work is to find the new physics. Okay, this is the same thing when I was back there. Supersymmetry was the thing that was going to unify all the forces of physics together. That was the exciting frontier of science. I think that plays a role to a degree, but also it's the philosophy of the way that science is done, that you have to look for materialist conclusion. You can't you're not going to see a cosmology paper say, well, I guess God did it, there he is, right there. You're going to try to find like Stephen Hawking used to say, he's looking for the explanation. He is looking for the explanation of everything, but he wants it to be internal. Okay? He wanted to find the ultimate equation, as opposed to the multiverse of everything.
So, okay, so that's helpful, because I think it's not. I mean, it's interesting, I think, to look at the body of literature out there and to say, okay, where do the majority of people land? But we recognize that simply a majority view of something doesn't mean that's true. And, some of the greatest, as you're mentioning, some of the greatest scientific discoveries are found when the person says, I think the consensus is wrong, and let me try to find something else, or let me continue to research this. Yeah.
There's a difference between the research and the philosophy behind the way science is done. The way that at university, I'll say at the academy, there is a preconception that you have to find a materialist explanation for things. So it's natural if you think, and many cosmologists, if you think that a absolute beginning to the universe implies a creator, the philosophy of science itself, the metaphysics behind the physics, and it is metaphysics, the postulates behind how you do science, are going to say, look for that exception. Look for that's operating within the rules of science. And so you're going to see, by the way, the private opinion of the scientists themselves can often be different. And I discovered that when I was in my interview process.
Hmm.
So, or maybe even more likely, and this is more true of earlier research. Well, like when the Big Bang Theory, which we're going to get to, started going, they would say something like, okay, this gets you close to the beginning, but it doesn't explain the beginning, and we're agnostic about what the meaning of the beginning is. You might have, if you're talking about what the attitude of the cosmologist is, a lot of the early cosmologists would take that view of things. So, on the other hand, you'd get someone like a Stephen Hawking, who was very philosophically minded. If you showed him a past eternal model, so there is no, or let's just say straight out beginningless model, infinite to the past, he would say that you haven't solved your problem. That merely looking at a universe that has a beginning, a finite time ago, seems to imply a creator. He would say even the infinite one does. And because you still have to put what's called a physical boundary condition on what the universe is like. It's just at infinity instead of this finite beginning. So I'd say he'd be on the opposite extreme. He was very philosophically minded, and that's why he came up with this thing called the no boundary model. Where'd that come from? It's entirely a metaphysical focus. Now, this model itself is physics, but the motivation was metaphysical. So that's how you get the. It's partially a selection process. The people who are attracted to it, the people who come in, but also the way that you conduct metaphysically. Like I said, there's a materialist focus on model building and the research. So it's not necessarily, I guess what I'm saying is it's not necessarily a good question about, let's take a poll and see
right
what they think about whether the universe is beginningless or not.
Yeah.
And that determines your belief system.
Yeah. So I think that's good. And so maybe now that is the perfect time to kind of move away from just, well, here's what a scientist believes, or here's what a Christian believes, and getting away from that kind of personal beliefs and opinions and ideas and views that are held. And let's say, okay, what is the evidence that informs the beliefs that people hold and the ideas that people have? And so kind of beginning, I know, I often read the history of, science and philosophy is that many scientists had previously believed in a past eternal universe, saw no need for that. And really kind of in the early 1900s is where Big Bang cosmology starts to kind of develop and point to the fact that maybe our universe actually had a beginning. And so kind of what is the initial evidence, both from astronomy and other models, that we would kind of look at to say, hey, maybe our universe actually is not eternal, but has a beginning?
Well, it all happens at about the same time, which is the late teens during World War I and the 1920s. The evidence from astronomy and from theoretical physics, we're talking about general relativity here, they came together very nicely. So what you're seeing in astronomy at that time is, now at that time they didn't even know for sure about galaxies. Okay, they could see what they could see, but the distance to things and the structure of the universe. So this is just about the time where they developed the means, and also theoretically, to tell how far things were away. And so one of the things they did is they said, well, we could probably look at, there's going to be this thing called the Doppler effect, where whether a entity like a star system, a galaxy, is moving toward you or away from you, it's the color of the light that you're going to see in your telescope is going to be shifted. If it's moving away from you, it'll be red shifted. If it's coming toward you, it'll be blue shifted. And so your initial surmise might be that we look randomly at objects in the heavens around us, that principle of indifference. Some will probably get as many blue shifts as red shifts, and they were surprised that they didn't see. They were almost all red shifts, as if things. What would make things look like they're moving away from us? That together with the initial work on relativity that Albert Einstein had put together. Remember, in 1905, he had three famous papers that brought him onto the scene. And later on, he was working with general relativity. So there's special, which is relativity with respect to motion, and general, which brings gravity into the equation. And Einstein built the first modern cosmological model, and he was surprised to see that his field equations looked to him like the universe was not static. It was either going to be expanding or contracting on itself. And in fact, he had what we'll call a fudge factor, which ends up being the cosmological constant, that he used in order to balance the equation, so the universe would be static in his model. We'll talk. There is still model building along the lines of the Einstein model. It's called the ESS, the Einstein static state. The problem with that model is that it was unstable. It's like putting a basketball on top of a hill. Is that the slightest perturbation is going to cause the ball to roll off the hill. That's what this model of the universe showed, is that tiny little perturbation, and they knew about quantum mechanics back then, is going to cause the universe to contract or expand again. This theoretical framework and further work on two people, Alexander Friedman and Georges Lemaitre, who was a Belgian Catholic priest, independently developed equations for a prediction of the universe, which matched Einstein's original prediction. And these Friedman equations, it's called the FRW, the Friedman-Robertson-Walker model, and it's the basis for what we call the standard hot Big Bang model. These equations predicted that the universe could be either, and probably likely was, expanding or contracting. So within that framework, it allowed the people like Henrietta Swan Leavitt or Edwin Hubble, Vesto Slipper, people in that time period, to take the evidence that they were seeing and interpret it in terms of a cosmological model, and say, this looks like an expanding universe. So that's what you have emerging. That's what led, I think it was Pope Pius, I don't remember exactly which number, in 1950 said, it looks like the cosmological evidence is very convenient for a beginning to the universe. That was probably the first religious leader to make use of this emerging evidence. Now, there were still efforts at the time by Fred Hoyle, for example, to say, well, could you take this evidence and still build a static model? And you could kind of do it, but the more that you would look at the evidence coming in, and there's other predictions, like you could make that came from astronomy, like, for example, the abundance of helium versus hydrogen in the universe, or direct evidence for that relativity looks correct, like that gravity will bend light. So there's a 1919, there's a solar eclipse, and an English theorist named Eddington makes sure that there's an experiment where we look to see if the sun appears to bend rays of light, and they were able. Einstein's predictions were proven out, that it does look like relativity is true. And today, We have like binary pulsar experiments where you can prove to the 22nd decimal place that general relativity looks like a very good theory. So all of these things are coming together well into, let's say, the 1970s, that seem to indicate that the static model has to be wrong, of the eternal static model, and that we do have an expanding universe, and the redshift evidence indicates that. And it was then uh, that's roughly when the second phase of the theorizing comes in, and that's where you get Stephen Hawking and Roger Penrose. And if you're of a certain age, you remember that's when the interest, even in the general public, about black holes and singularities come in, and the theorizing gets even better.
Yeah. Now, so before we get to that second phase, is it, I remember teaching back in, I don't know, I want to say like 2018 or 19, when there was an experiment that was heralded as being an amazing experiment that proved an aspect of general relativity that had never been proven before, where they had lasers set up. And the idea was that if general relativity is true and we have this fabric of a space-time universe, that black holes or something, if they were to collide, it would create a ripple effect, and that it could actually stretch the space-time, the fabric of space-time. And then they had these lasers, they would bounce off of each other in different directions, and something happened to where it squeezed one of the lasers, and there was a difference because of some collision of black holes somewhere. I don't know if you have any idea of what I'm talking about, but I remember teaching around the late 2018, 19, somewhere around there, and that experiment coming back and saying they predicted that this would be true if general relativity was true, and we have now have scientific verifiable evidence that this actually does happen, and that our space, the fabric of our space-time universe has stretched and contracted because of this ripple effect, and therefore just another confirming piece of evidence of general relativity, which is kind of within the phase one that you're talking about.
Yeah, I think. I remember some gravity wave experiments where they were looking for evidence of events like that happened in deep space and would be strong enough, like two black holes colliding, that would cause an effect strong enough that we could detect it. I can't remember how that turned out.
I think it's the LIGO, LIGO. I just Google searched it. The LIGO Laser Interferometer Gravitational Wave Observatory. And I don't know if it says here what that date was, but anyways, I remember that being a huge thing. I think Caltech's a part of this, and I remember that being a huge discovery when I was kind of, looking at all this stuff from a distance, going, "Wow, that's really cool." Actually, this says 2006. Gravitational waves detected 100 years after Einstein's theory. So 2016, sorry, 2016 is when these gravitational waves were detected. So, anyways, so awesome. Okay, so this is kind of the initial stuff. Now you're talking about we're moving into phase two, where now you have Hawking and Penrose producing their model of singularity. Kind of what more to the puzzle does that create? How does that change things, or how does that build on what we previously have seen? What's happening in phase two?
A way of thinking about it is, okay, think about the evidence that they had at the time. And here's a simplified way of thinking about it. Think about the Russians back at, remember, that's Cold War was going on back then. And there was a very strong bias in Soviet astronomy to find the eternal universe. And so they're very interested in looking for an ability to do past eternal universe. And so even if it looks like, okay, if we're expanding into the future and therefore contracting into the past, does that mean that everything contracts into one origin or not? And the answer is, it wasn't obvious that was the case. And we'll get when we get to the quantum gravity stuff about where that discussion is today. But okay, so there's a question right there. What happens when, in the limit, as you look to the past and you get very strong gravity effects as the mass density of the universe? Think of these types of models. Think of it like a fluid. Think of uniformly, just for what we call a toy model. The universe is a fluid of particles, and it's uniform. And you start compressing that together as you go to the past, and the gravity effects become greater. Now, what's going to happen? Are they all going to congeal into something, black hole, or are they all going to shoot past each other and maybe keep going into further into the past? You get an expansion. What is going to happen? This is the sort of thing that the Hawking and Penrose are studying. They want to use the gravitational field equations to make predictions about when. Think of there's these things called world lines, and us sitting in our chair right now are we are still on a four-dimensional world line, which is tracing out a path through time and space. And if you think of us as a center of gravity in a particle, you can think of it that way. And so just think of any random particle in the universe, it's on a world line. And what happens to these world lines when you look to the past? Is there like a focusing effect where they get focused together? And do you eventually come to a point where they have a common origin, or not? Do they shoot past each other into an infinite past? And what Hawking and Penrose did, and this is again 1970s, they put together they were able to prove a series of theorems where they could show that this world line, imagine you're a particle on a world line, they would focus together, and world lines in its vicinity we're going to focus together into a singularity where it appeared that the laws of physics break down, even the beginning of time. And so it would, as I say in my article, there's a 1984 textbook on general relativity written by Robert Wald. It looks like this particle, if time is if you're looking into the past, it looks like it comes into being at a particular time, and then it, if you fall into one of these singularities, it looks like you end your existence, and the equations will just say that and stop. So what does that mean? What these singularity theorems showed is that the Friedman-Robertson-Walker universe, the one that matched very well the redshift evidence that we see around us for the distant galaxies, it showed that there should be that the universe itself, all of the world lines for all the particles in this in this fluid, in the toy model, will come into being a finite time to the past. So they were able to show that no, it looks like there really was a beginning to the finite past. Now, a more skeptical conclusion would be, okay, you get to a point where the laws of physics break down and we don't know what happens there. Okay, so as I said before, there's other physicists would take, in terms of a philosophical conclusion, would say something like that. But it looked like it was difficult based on the evidence of the time to predict a past eternal universe, unless you could get a universe that was cyclic in nature, which means that it it will expand to a point, and just like throwing a ball up in the air, if it doesn't have escape velocity, it's going to turn around and fall back to Earth, right? Well, the universe can be like that too, depending on how strong the initial expansion is, it eventually can stop and collapse. And can you get a situation where the universe collapses into a singularity in the future and then rebounds and then does that over and over again? And that ended up being the model that those Soviet scientists preferred. And that's where.
Sorry,
No,
you
go
said
ahead.
that's where.
Is it so? Yeah. And then the question. So yeah. So the key thing was these singularity theorems that Hawking and Penrose put together. But if this brings a philosophically difficult conclusion, and remember the way that the academy works is generally it's going to, yeah, I said, you're not going to have a cosmology paper that says, "Oh, we found God." What you're looking for is, if you can find a materialist answer, you're going to find it. So the there's going to be a strong focus from that perspective. Can we find a way to get a past eternal universe? And that's the interesting research to be done anyway. So Hawking and what this does is, what you see is that there's phases in cosmological exploration over time, and Hawking and Penrose said, well, there are some exceptions to our equations, and if one of these exceptions applies, you could still get a past eternal universe. And it's precisely those exceptions that began to be explored.
And so with the fact that there are always exceptions, right? And so the inflation theory is presented as being an exception to the Hawking-Penrose singularity, and there's, you know, as you already just mentioned, there's you know, people believing in static universes or cyclical universes where it's just, you know, continuing to, you know, contrast and expand. In what way can we say, with all of these exceptions to all of these theorems, that there is scientific proof or evidence, or have any sort of confidence at coming to a conclusion ourselves when there's all these different views held by different people and there's always exceptions to the views that they hold?
Okay, well, you're throwing a difficult question at me. Apology. It's funny because Albert Einstein, he was once, I think this was back in the 1920s, and he was once asked why he went into not cosmology, but studying general relativity and deriving it when he could be doing all these other things. And what he described cosmology as much easier than trying to solve the problem of hunger or disease or something like that. He said, "Oh, cosmology is the easy thing, so I'm going there." So, but cosmology, there's you have to be patient and you have to be relentless. Now, I know that this question. Let's go. Why don't we just go right to the crux of the matter? There's very high stakes in this question. And this is where interest comes into this question. This is why it's not just some footnote. People are very interested in whether God exists because that has consequences for their lives. So you'd like to know right now what the result is going to be when there's still research ongoing. And another thing that I say, and this is especially in the Christian community, because there will be a crisis a week in cosmology. Well, there's some new model that comes out that says, "Oh no, somebody found a new past eternal model. Does that disprove everything that we believe?" No, just wait a week, and that generally doesn't tend to prove out. You've got to be, and this is true in my work as well. When there's a new contention out there, about, okay, here's some new way using something called ghost particles that we can make a past eternal universe stable. For this is one of the things that's in my paper. For example, it used to be unstable. Remember what I said about the Einstein static universe? They say, oh, you know what? But if we imagine this exotic type of matter, we can get a universe that is stable. What you have to do is you have to be patient, and you have to wait to see what the other theorists do. This is the peer review aspect. Wait, this is what I do. Okay, I wait to see how the community interacts with that work and where the trend is going. And in the article that I reported in originally 2009, that's the result of this work. I'm taking cases where there's been a lot of discussion and conclusion, and painstakingly over time, what you see is a trend developing that looks stronger and stronger over time, that you can still develop models that look past eternal, for example, but it's more difficult and exotic over time. So I don't know if that answers your question.
Yeah, it does, and I think it triggers a few things in my mind. I think number one is I've seen a few comments here in the live chat of recent discoveries of the James Webb Telescope, and you mentioned Jeff Swearink at the beginning of the show. I went to a lecture from him about back in February on what does the James Webb Telescope tell us about modern cosmology, and in this I asked him the question. And for those who don't know, Jeff Swearink is an astrophysicist at Reasons to Believe, as well as done a lot of research at UCLA. And I asked him early, right? Here's what you're talking about. Just be patient. Just wait. Early reports were like James Webb Telescope blows the Big Bang out of the water and shows our universe is more like 26, billion years old, not 13.7. And I asked him about that, and he goes, "Well, look, here, that's what the original report said, because based on our current understanding of how galaxies formed, to get these large galaxies this early on in the history of our universe, you would have needed more time, and that's why people started suggesting 26 billion." The issue, though, is he says there is overwhelming evidence and multiple lines of evidence that all point to that about 13.7 billion year old range. And so what this actually is showing us, when we kind of waited a second and gave it more time, it's probably just showing us that our understanding of galaxy formation is off, and possibly galaxies can form faster than we previously thought. Not that the Big Bang just gets completely thrown out of the water, but that would be one of those things I think that you mentioned of just like, oh my goodness, initial like evidence and everything is, this chaos. And it's like, well, hold on a second. Let's evaluate this in light of what we see and get some peer reviewed against it. You comment on that.
Yeah, Ryan, this is not new.
Yeah.
You go back and look at the last 40, 50 years of cosmology, and you compare that to what the astronomers are doing with the direct evidence of what they can see. And usually they've got 2, 3, or more ways of estimating the past age of the universe. And these clocks tend to disagree. And so there's a crisis in every era. Let's say every 5-year block. They say this clock doesn't agree with that clock, and it says that the galaxies would have had to form before the beginning of the universe. Oh, I guess that disproves that. No, okay. If you go, here's what you can do. You can go back and look at how those clocks ended up aligning as we learned more over the last 50 years. And you could say, we have exactly the same phenomenon today, where the Webb telescope is showing us, oh, these clocks don't agree fully. So what's the effect of that? Does that throw out the otherwise overwhelming evidence that you have for the Big Bang? Or could it be that there's some details, like you said, of galaxy formation that we don't understand? Far more likely the latter than the former. And this is, this is the pace of science and how it works. But like I said, you can look back and see that the clocks achieved harmonization on all the previous crises. I wonder if it's going to happen. I think so.
Yeah, and I think so. I think the other thing that your comment, your response, kind of triggered in my mind was the fact that there's always other arguments. There's always counter arguments, and there's always exceptions. And I think one of the values I saw in your chapter is not only that you didn't ignore these. It wasn't like that you only found evidence that supports your view and said, "See, look, everything supports a past, finite universe, and there's no exceptions whatsoever." It's like, no, I want to show you everything that is out there, so you can actually see both sides and hear all the arguments and make that fair case. And I think there's a lot of value to that. But I think the big thing here is this, is I saw a video by a skeptic TikTok account the other day. It said something to the effect of, and I'm going to do a review of it on my YouTube channel. It says like, if Jesus existed, and that's still debated, and then they go off, and it's like, well, yeah, I mean, and I respond, I said, it's kind of like saying, if the world is a circle, and I mean, that's still debated, it's a sphere, that's still debated. It's like, well, yeah, I guess, yes, there are debates that flat earth or, from Jesus mythicists, but really, is that a debate worth listening to? Or just because there is an exception or a debate, or there's someone who disagrees, does that mean that the exception or disagreement or debate is of equal weight and equal evidential value? And so I think I often see online people just throwing out, well, I mean, there's another view. This happens in conversations where people say, well, there's an exception, or there's a different view, there's a different model. And it's like, yeah, that's true. There are other models. Can you show me why you think your model actually better matches our understanding of the universe than what this model is? And let's look at and compare the models rather than simply just saying, well, there's other models out there, Ryan. Well, yes, of course there are other models, but let's evaluate them.
Like I said, you can see patterns if you just look at the cosmology, and you can see the classes of models and why they exist. And so if you look at cosmology in the last 50 years, it's based upon these singularity theorems, or to be more general, incompleteness theorems, which means the world lines that don't extend to an infinite past, and the exceptions around them. So, for example, you mentioned one. So this Hawking-Penrose theorem was based upon ordinary matter. That's completely normal assumption for them to have had in the 1970s, in late 60s, when they're doing their research. But then, along comes Alan Guth and others who independently were able to derive this. There's probably this inflation phenomenon. There's other puzzles that get solved if you assume that there is a form of matter which isn't like the ordinary matter that exists on Earth. That perhaps that there's a form of matter where it obeys gravity, but gravity is a repulsive force for this, not an attractive force. And suddenly, some of these cosmological puzzles that they had back in the early 1980s, like, for example, one of the things that they discovered, one of the things that made inflation attractive, I'll bring it out, is that even when you look to the past of the Friedman-Robinson-Walker universe and say, oh, particles are getting closer together, because as I look toward the past, everything is focusing in on this thing called the singularity, right? Okay, but it turns out that the ability of all of this matter to talk to each other, to be in interaction, so it can do things like form galaxies later in the universe, for example, it turns out that the math works out that they are what's called causally disconnected, that they couldn't possibly be talking to each other. So we have a puzzle. Is how do you get a Big Bang explosion, so to be, a creation event, and this cosmic fluid that builds a more or less homogeneous universe with some ripples in it, if nothing can talk to each other. And it turned out that if you allow this form of matter, which has ultimately results in a repulsive force. And if you read my article, it has a little bit more on this and what it is. And oh, by the way, this is the fudge factor that Einstein included back in his original model, what's called the cosmological constant. What that effect would have is it would inflate the universe, make its initial growth rate is so high that the math then works out, and it allows for there to be from a singular or near singular origin point everything to talk to each other. And there were some other puzzles that this solved too. They were, if you know what a magnetic monopole is, for there's the exotic particles called magnetic monopoles, that there was a prediction of a certain density that they would exist in these Friedman Robinson Walker universes, and it wasn't seen. There was ways that they could tell that. And what this inflationary event would do would blow up the universe, make it so big so quickly that the density of those particles would be so sparse that it resolved that problem. So there were 3 or 4 problems like this that right around the time of the early 1980s get resolved by this event. But guess what? This cosmological constant doesn't obey the condition in the Hawking-Penrose theorem. So maybe this allows a past eternal universe. So this excited a lot of people. And what that led to is a flurry of exploration for not just past eternal universe, searching for past eternal universes, but say, could there be singularity or incompleteness theorems that show you still have the same problem as you look to the past? And in fact, there were. Like there's a cosmologist named Alexander Vilenkin, for example, who's very interested in this. So throughout the 90s and the early to mid 2000s, he's out there doing research on other singularity theorems and saying, is this true even though we've got a cosmological constant, this really exotic type of energy which is repulsive with respect to gravity? And in 2003, he published a paper along with 2 other theorists, one of them Alan Guth, the one who was famously proposed along with 2 others, I think, whose names escape me at the moment, back in 1980. And this is called, they developed another singularity theory. They actually 4 or 5 of them they did, which seem to predict that even in the face of inflation, if you look to the past, you're still getting a singular beginning to the universe. And this singularity theorem has been stubborn enough that it's still around and dominating cosmological discussions to this day. So, in fact, Alex Vilenkin, if you look him up on Amazon or somewhere, you'll see that he wrote a book about this, and it's at a general level, and he has some nice examples in it where he explains, if you're a spaceman on a spaceship and we follow, remember, your world line to the past, you're going to get the same issue with the redshift as we push you into the past, and you end up proving that your world line cannot be eternal. And so that leads one to the suspicion that there's a singularity to the past, just like the earlier Hawking-Penrose theorem predicted. And so what did that do in the middle 2000s up until the time where I wrote the paper? And it's still pretty much active today. That led to, well, is this what we say in philosophy is a knockdown conclusion? I guess we have a beginning of the universe? No. Okay. And in my work, I never make a statement that strong either. What it shows, here's another clue. Okay, the initial evidence seemed to point toward a beginning to the universe. Then Hawking-Penrose, with their work with the black holes, said, you know what? This seems to point to a beginning to the universe. Oh, can we find exceptions? Yes. Oh, but there's another singularity theorem which seems to foreclose those exceptions. And so what you're getting is, over time, it gets more not impossible, but it's getting more difficult to build models which can demonstrate that they're past eternal. And I'll let you.
Yeah, so I think Okay, so I think the big one here that I want to get to as we're getting running out of time is really what we've seen so far is that yes, there have been quests and studies and theorems and ideas and exceptions presented to try to point to possibly the existence of a past eternal universe, but each one has failed for different reasons. And these theorems that have been presented, like the FRW model you mentioned, like the Hawking-Penrose singularity, Borde-Guth-Vilenkin theorem, really have continued to point to a beginning of our universe and kind of withstand some of the criticism. I think one of the biggest things I hear of recently is just with all of our new advances in quantum gravity and the quantum level, and maybe there's this stuff going on at the quantum level that we just don't understand. And so how can we say that our universe had a beginning when really we maybe are not quite sure? So how in recent years, how have some of these quantum gravity approaches affected our understanding of our universe having a beginning or being eternal?
Okay, yeah, so that's one of the original exception conditions. It's the falsity of general relativity. What if you get to this point where the gravitational forces get so strong that you need a new theory? Okay, and at this time, well, this is what I was doing with at A&M back in the late '80s. Back when I was a student, that's where supersymmetry comes from. That was an attempt at the time, because there's another puzzle in physics that it can you unify the because gravity initially there's a reason why it's called quantum gravity. It's because the other forces had been theorists were able to marry them to quantum mechanics. Call that the theory of the very small, just for purposes of this discussion. The so But gravity was what's called a classical theory, and eventually gravity has to harmonize with uh, quantum mechanics, because quantum mechanics basically, what do particles do at the level of the very small? Think of it that way. That what happens when you compress a universe to so it is very small. If you like, think of it that way. Do you get a new law of physics? And that's where string theory comes from. That's where loop quantum gravity comes from. That's where there's dozens of theories out there about what happens when you get to the what's called a high curvature region. And so maybe in one of these theories, it explains the singularity, and you can still get hey, maybe a cyclic universe where you get a bounce, and then that our particular bubble of the universe, this inflationary bubble that we live in, maybe it has a past history through what we formerly would have called a singular, now a near singular condition. And so what I found in looking at those conditions, well, first of all, a lot of these quantum gravity theories that are constructed are still constructed from the perspective of the what I'll call it a QG plus, or a quantum gravity plus theory. And there's a thing in physics, say, well, it's called a perturbative theory, where you take classical field equations and you quantize them, and a perturbative theory is, what if there's only a small effect? So what if I get to the point where Einstein's equations are good and they start to break down, and I start making corrections to those equations based on predictions from string theory, say. Okay, so when you look at these theorems, here's a way to think about it. A lot the models that come out of that, a lot of these models still can be built in such a way that you don't get a singular condition, and then you say, oh, that's like the Einstein static state, for example. If you don't get deep into that region, then Einstein's equations still apply. And the same types of arguments that I use in my paper to, okay, can you get a past eternal universe in a along those kind of models? Those arguments would still apply to it. So things like entropy arguments, can you get if disorder grows over time and it's been growing for infinite time, then would there be an entropy objection to a model like that? Or similar to the effect that broke the Einstein static state and breaks a lot of the modern models which attempt to do that, where the usually due to something like a quantum mechanical effect, these types of models that I'm talking about right now have to do two things which tend to be opposed. These past eternal models, they have to be quiescent for an eternal amount of time until you get a Big Bang like event. Okay, in other words, they got to be quiet for eternity, but then you have to have a Big Bang. Okay, if you think about it, that's like the irresistible force versus the immovable object. I've got two opposed assumptions that somehow have to harmonize in one of these past eternal models. And physicists have to figure out how to make those two things agree. And usually, what you find out, and especially if you look at the work of Alex Vilenkin, who I've mentioned before, something like a quantum perturbation sometime over all infinity is going to break that balance, and you're not going to get a past eternal model. So that's one way. That's one way of dealing with the quantum gravity model. A lot of these quantum gravity models, however, do go into what we call this high energy region where general relativity is going to break down. But what you often see in these models is they'll predict that space and time itself cease to exist. That you get, because they attempt to explain at the lower level what, like this idea of a quantum foam, for example. But here's the thing about a model like that. You're If that happens, and a lot of these models are like that, yeah, Einstein's equations break down there, but guess what? Time comes, if you look to the past, time ends a finite time to the past. Conceptually, philosophically, I'm getting the same effect in a quantum gravity model that I'm getting if you purely look at Einstein's equations. So you can make a list of all the different options that you can get by pursuing quantum gravity backwards through those two types of options. And it still looks like you end up with a conclusion that most of the time you're going to end up with a prediction of a beginning, a finite time to the past. So what I'm saying is that objection ends up getting dealt with. And in 2014, there was a debate at what's called the Greer-Hurd Forum, which is at the Baptist Seminary in New Orleans. And every year they hold on some topic of interest a debate like this. And that year, the William Lane Craig debated Sean Carroll, one of the most prominent cosmologists in the world, and I was on his team. And I spoke about this very subject at at that forum, and it's online if you want to look it up. So this is an example of what you were saying before. This is an objection, not just that, let's say, an atheist would have to my work. It's an objection that I myself would have to it. I say, well, oh, up till now, I've only looked at general relativity. You have to go past that and see what the scientists are doing with quantum gravity. Do the same kind of issues still apply? And it looks like, in general, that is still the case. So what you're getting is you're still going to see, if you look in the cosmological paperwork, the model of today. You're still going to see this model, that model, that model, and that model that purport, well, I can exploit this exception condition. I think I can still get a past eternal universe. But what I see is don't miss the forest for the trees. This is what I was. If I remember one thing from my talk here, look at the course of time over the last 50, 100 years, as scientists carry out their work painstakingly, relentlessly, patiently. What's happening over time is it's getting more and more difficult to build, like, to construct a model that obeys uh, simplicity, like Occam's razor, if you know what I'm talking about. The models are getting, oh, can I still find some obscure exception condition that could give me a past eternal universe? Yes, you can still do it. But because of the investigation and these repeated incompleteness and singularity theorems over time, or just the nature of quantum gravity, where it's predicted to break down time and space itself, if you don't miss the forest for the trees, I would say it looks very strongly like if you're open to theoretically the idea that the universe could have come into being a finite time to the past, it looks like that's where all the evidence leads, and it's getting stronger and stronger over time.
Yeah, I think that's helpful. And I'm looking down because there's a quote in your chapter that I was trying to find that I was like, oh, this is so good, and I want to address it, and I want to bring this up. Yet you have a 100-page chapter that you co-authored with William Lane Craig, and I could not find the quote that I highlighted. But I think let me put it this way, because I think what hopefully everyone is hearing is that I just think in this whole conversation, never once have we said God did it. This conversation is specifically just simply looking at, in the last 100 years of scientific discoveries, does the science more reasonably or more likely show that our universe had a beginning, or that our universe is eternal? And we haven't even really gotten to the complete, issues of that, or where that leads. That is the fundamental question that we're asking. And there's obviously all of these different theories and views that you have surveyed, and we're trying to make sense of as we go about the hard work of figuring out, does our universe have a beginning, or is it eternal? And so let me just ask you this, based on everything that you've studied, where would you place your confidence level that our universe does have a beginning versus maybe there's a possibility there's a past eternal universe? Kind of where would you kind of put yourself as far as how confident are you that our universe had a beginning?
I mean, I think it's far more likely than not, but it's not 100%. But if we bring back the kalam argument into this, and we do as William Lane Craig suggests, are the two opening premises, the second of which is the one that I defend, which is the universe began to exist. We didn't even get into the philosophy of time, and we don't have time for it.
Yeah.
It looks to me like that it's much more likely that these premises are true than false, and therefore that the conclusion follows. And what is the conclusion of the kalam argument? That you have a transcendent creator. You've got this entity which transcends the time and space of the universe and is extremely powerful. And let me just bring the volume here. In the third section of our article, Craig suggests that if the universe has a cause, then an uncaused personal creator of the universe exists, who without the universe is beginningless, changeless, immaterial, timeless, spaceless, and enormously powerful. Now, that does not carry you directly to Jesus Christ and the Christian conclusion. This is what I'll call the simple kalam argument. But it does suggest strongly that there's this powerful transcendent creator. It powerfully suggests that an entity like Christianity says exists really does exist. So it's it's what premises are true or false, arguments are sound or unsound. It's a sound conclusion. It's a rationally justifiable conclusion. So me in the 1990s, when I'm surveying, before I get into that, and I'm looking at Hugh Ross's Creator in the Cosmos, and I say, this is rationally justifiable. Faith in this type of a creator is rationally justifiable. It's an open door. It's an opening on the what we call natural theology, basically the rational side. What can be known just from reason and evidence as opposed to revelation. It's an open door that says it's rationally justifiable to believe in the God of the Bible and Christianity.
And I think that's helpful because, look, I've always said this, and it's like, I want to be someone who, look, I form my beliefs and opinions and ideas and my knowledge based on the best available evidence at that time. And I don't want to say, well, I don't have any evidence for this, but I believe it. Maybe one day we'll find it. It's like saying, hey, what do we have right now? And what do I believe based on that? It's kind of like, I always say it like at a criminal trial. It's like the jury has to make sense of innocent or guilty based on the available evidence at that time. And if a jury member went, well, I know everything now looks like it's pointing to guilty, but maybe one day in the future we'll find evidence that the person is innocent. And so I'm going to say innocent now because we might find something in the future one day. You say, well, hold on. You're being asked to make a decision based on the evidence that we currently have. Now, if that evidence changes and in the future we find something, then are you willing to switch your mind? Great. But that's how I've often tried to be. And so I think with this evidence, and the way I look at the cosmology is to say, look, the evidence that we have right now and the evidence of the last 100 years seems to continually point to the fact that our universe has a beginning. And so I'm going to draw conclusions that I have based on that evidence. Now, in 5 or 10 or 50 years from now, we find evidence that guarantees like, nope, our universe is past eternal. Okay, well, then let's make sense of that. And views might have to change at that point. Or I guess they will change if the evidence is clear proof. But I'm not going to hold out a view in the hopes that maybe one day something changes. I'm going to say, okay, based on what we currently know, what conclusion can we come to? And I think that's where this argument is good, is that the current evidence really does point more favorably in the conclusion that the universe had a beginning. And if things that begin to exist have causes and the universe began to exist, then it points to the fact that our universe does in fact have a cause. Yeah, and let's continue to encourage the cosmologists to study this question and create these exceptions to see if they can find something that disproves that beginning of the universe theorems.
Yeah, I mean, we have to remember that the way William Lane Craig puts it is rational evidence of this sort for as far as what brings you to belief in God. Can I grab some atheist and shake them and say, here's evidence. Can I bring you through evidence to believe it? No, we're not saying that. But I'm saying it is like the open door. It's like, for me, the INTJ troublemaker, where I just have to question everything. And that's what this volume is about. It's not just this. There's, I forget how many chapters there are, 13 different chapters, and with different arguments in it, where what it's going to show you is it's rationally justifiable to believe in the creator God. And by the way, there is a resurrection argument. That's Tim and Lydia McGrew. So are there arguments that lead directly to Christ in that book? Yes, there are. Okay, so I encourage you to. That book is now affordable too. By the way, when it came out, it was. Now you can actually afford it. So it has a pretty good resurrection argument in it too. But the point of the volume isn't to grab someone by the scruff of the neck and say, I'm going to convince you through coercion, intellectual coercion, to believe in God. You can't do that. And the Christian truth claim, the Christianity does not suggest that. It's ministerial rather than magisterial. It's not. It's helpful to troublemakers like me, and there's a lot of troublemakers like me out there that can be persuaded by rational evidence of this type. Like, for example, my wife doesn't need this. My wife came to believe through a religious experience Okay, she doesn't need to sit here and study Big Bang theories and things like that in order to come to belief in God. Uh, but there are people out there who are genuine seekers and are open to it. And I've also coming out of the Greer Herd that was in 2014. There was a book put out from that called God and Cosmology, where, and it's balanced, the atheists and the theists all have articles in there, and I have an article in there where one of the things that I'm discussing in there is what the use of this evidence is, and there's also a valuable function for the public square. So if you ever do discussions, like I know you do, Ryan, about would it be valuable to be able to argue for um, public policy decisions based on Christian beliefs? Well, you better convince the public at large that Christianity is at least rationally justifiable, even if the whole public doesn't adopt it, in order to get a hearing at the public square. So there are many uses for this, even out and within the church itself as well. I think that evidence like this, that heck, I think every church ought to have a class, but the class isn't to go learn general relativity. No, there's only a few people that need to go do that, and those are the troublemakers. But what I think everyone should learn is that your faith is rationally justifiable, and they should learn where the resources are if they need those resources. That's part of the function that you're fulfilling right now, is showing where the resources.
And that's hopefully what I want to do. Is I want to be that translator of finding the resources, bringing it to people, and opening up that conversation. Hopefully, training people to think well and engage in good dialogue. Now, the question came in twice now. And in the last Firebender, I was trying to find the quote in the book that addressed your specific question. But James, I don't know if you remember. You mentioned someone in your chapter. This is the quote I was trying to find. That, in a sense, came to the idea that, look, I don't know how to explain this, but in a sense, like I'd rather take an uncaused natural cause of our universe than to agree with a supernatural uncaused cause. And so to point to some sort of God what I believe about a natural explanation for the beginning of our universe doesn't fit with the evidence, but I'm rather going to take that view than adopt a God explanation. And you had some quote from someone in your chapter on that point, and I can't find it. But the question kind of just came in of, like, with Graham Oppy, of why not accept and just say, look, we may not know, but why not just say, hey, there must be a natural cause out there, or some sort of natural uncaused cause of the universe. Why posit, or why present this as being a supernatural? Why present this as being God as the uncaused cause of the universe?
Well, the Kalam argument logically leads you there. Okay, the cause of the universe has to be transcendent. If the conclusion follows, then the cause of the universe, I mean, the idea that the cause of the universe is within the universe itself is probably philosophically dubious. You've got, we're starting to get to the first premise, but that's a whole other thing. the it's the You're led to the cause, whatever it is, whoever it is transcendent from the space and time of the universe. So it has these key characteristics of the God of the Bible. So that's one of the things I like about the Kalam argument is you 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 can't end up with you have to end up accepting that there is a transcendent cause, and that has consequences. Then the monist, or the purely materialist view of the universe on its own, it's false. It's wrong. There is a transcendent reality that one has to deal with, and it appears to be in a causal relationship with the universe. So there's also other arguments which we can't get to now in any detail. But if you look at the cosmological design argument, which that's one of the chapters too, Robin Collins, I hope you get through to him.
Yep. That's the next interview.
That appears to show genuine personality in the creator. Okay, that's something that you're not going to get there straight from the Kalam argument. That's where it's not just a cumulative case argument that you put 13 arguments together and it forms a stronger conclusion. That definitely happens. But there's different sides of the creator that you're going to see. And that's one of the things which is in his evidence.
Yeah. So here's what I just want to say is that we are running out of time. And earlier today, I was sitting down trying to figure out, okay, what are the future shows going to look like? Because I have through the end of April planned out. Next week is going to be walking through the Student Guide to Philosophy, how the Christian intellectual tradition has shaped philosophy. The week after that, it's going to be looking at the evidence for the resurrection. And then I was like, okay, May 6th, what do I do? And as I was walking through this chapter, I thought, there's probably going to be a lot that we're not going to get to in this chapter, because what we also have not addressed are the two philosophical arguments for a beginning of our universe as well. And so this is not conclusions that are just come to based purely on the scientific evidence, but there's also philosophical reasons to believe our universe had a beginning. And then there are the implications that this argument presents, which I'm seeing come into the live chat right now of, well, why do you think the cause has to be transcendent? Or why does it have to be the God of the Bible? And that's a whole other set of follow-up implications. If this argument is good, and that everything that begins to exist has a cause, the universe began to exist, and therefore our universe has a cause, then the questions should come of, okay, well, what is that cause? And so what I'm going to say is I'm going to do part 2 to this discussion on May 6th for everyone listening. And I wanted to address a little bit on the philosophical arguments for a beginning of the universe, as well as getting into the theological implications of what this scientific evidence points to. Because I really did want this show to focus mainly on the scientific evidence of pointing to the beginning of our universe. Now, I did find... Oh, yeah, go for it.
There's a philosopher named Paul Valery, who I mentioned in one of my articles, and he has a simple, pithy statement, which is that the simple is wrong, but the complex cannot be understood, or made concise is another way to put it. So we're struggling with that difficulty. The subject that we're talking about, if we make it too simple, it's wrong. And there's something to point out. But if I make it too complex, and there's my 100 pages, I'd say that's why there's 100 pages there. Someone who wants to put in the time, there's a lot more detail in there. But we had, I don't know, we were supposed to be 90 minutes. I think we went up past that, or maybe we're right on.
We're at 4 minutes away. Yeah.
There's only so much that even with 90 minutes using verbal communication that you can get to on this topic.
Yeah.
The cosmology is involved and difficult, and you need some background in order to be able to study it. And so, however, the reason that the Kalam argument is so strong, and why it's probably other than the resurrection argument, it's the number one argument out there, is people have this powerful intuition, I think. Why is it that every cosmologist, every prominent cosmologist ends up writing a book about the beginning of the universe, or the eternal universe? It's because this resonates with the public. So even though there's these difficult details that are hard to follow, and the devil's in the details, we can speak to people about their intuition. And the same thing applies to the design argument. People have an intuition for this, and that's one of the reasons why the Kalam argument is good for the purpose that we're putting it.
Yeah. And so, I appreciate that. And I found the quote I was looking for, J.L. Mackie, and it was actually in response to the first, it was objecting to the first, it's a quote I was thinking of last Frybender when you asked that question, but he objects to the first premise of that everything that begins to exist has a cause. And here he says, Mackey thinks in this particular case, the theism implied by affirming the first principle is even more unintelligible than the denial of that principle. It makes more sense to believe that the universe came into being uncaused out of nothing than to believe that God created the universe out of nothing. And so, again, I think that is the question that we have to come back to is, where are there biases and presuppositions and everything kind of affecting us, where this one person says, yeah, I'd rather hold to the idea that, or I see the implications, the theological implications of this argument, so I'm just going to deny it rather than believe that God created the universe out of nothing. And so that's where, again, I think what I'm trying to do here is to say, okay, where does the evidence point to? And if it really does point to our universe having a beginning, then to follow the evidence, honestly would lead to our universe having a cause. And then we have to ask that question. And so, if I want to give a quick little preview of maybe May 6 is some of the properties that this chapter then ends with. And I think William Lane Craig wrote this section of it, but the properties of that first cause. If you then ask the question, if the argument's good, the universe had a cause, okay, what is this cause like? What sort of properties can we get based on the scientific evidence that we have? The chapter argues for a beginningless, changeless, immaterial, timeless, spaceless, powerful, and personal cause. And then I think it quotes Thomas Aquinas that says, well, that's what everyone means by God. And so that's, I think, what we can argue for based on the scientific evidence that we have discussed today. So you can join May 6th for that conversation for all of you that want to participate there. And then I will be taking calls and questions in that show as well. So James, I think ending here, you have a chart that kind of breaks things down simply, where you talk about, where you have model, average, different models that are being presented, and how each one really does have conditions that can keep coming back to beginnings, where you have expanding models that point back to singularity theorems, and you have asymptotically static models. So you have static models that have, there you go. So words I can't even, asymptotically static models that have metastability problems, or you have cyclic models that really kind of run up to the second law of thermodynamics, or you have contracting models that have acausal fine tuning. And so really the idea here is trying to point everyone listening to say, okay, let's consider the models that we have and what sort of problems are created with each one. And really, I think there's good reason to believe that we come back to something different or about these models that point to beginning is really matching well. Is that a fair way to kind of summarize the whole conversation?
Yeah, the Cliff Notes, if you're just taking the Cliff Notes version of this 100-page contribution, it's that one little chart. Here's four different ways you deal with the expansion, contraction, etc. issue. And there's the four things that make it very difficult to envision and build past eternal models. And the same thing applies to quantum gravity. So the article that I wrote for the God and Cosmology book coming out of that the Sean Carroll debate has a similar chart for space and time breaking down to the past due to quantum gravity. So just take those two little charts, and that helps to understand why it's not impossible, but it's difficult. It's where I say that if you don't miss the forest for the trees, it looks like over time cosmology is moving in this direction, that it's extremely difficult to get a model to behave that way past eternally. And Stephen Hawking himself, like I said at the beginning, we didn't get a chance to talk to his model specifically. He was as much not a fan of past eternal models as he was models that had boundaries to the finite past. That's hence his search for something called a no boundary model. For him, either one of those implied a God, a creator God.
Yeah. One question came to mind that I forgot to ask you during the conversation. I'm just curious. Do you find, what would be is it just mere curiosity to try to, turn over every stone, or what would be the reason to continue to find exceptions to a finite universe? Why continue to search for that past eternal universe? Or is it just like, hey, we just want to make sure that every single stone is overturned and we are coming to the right conclusions?
Oh, there's so many answers to that.
Yeah.
As I said, the stakes are so high.
Yeah.
Okay. So you're going to keep looking. Okay. I said the philosophy of how science is run in the academy. Again, the sexy work in cosmology is to find the exception, never to find more proof of the existing paradigm. That's not going to get you grant money, and it's not fun. Okay, the thing that's fun is to go find the exception. So that would be, there's many reasons why, and you don't want your science, you want your science to be alive and thriving, and that's going to happen, like this James Webb, the issues where we have different clocks for the age of the universe, and they disagree. That's going to keep happening. The current clocks are going to get resolved, and they say, oh, we have one time again, and it's whatever the number is. And then in the next decade, we'll find new ways to look at the cosmos, and again, the clocks won't agree. And the science will go on, and people will keep looking for the exceptions. So, as you said earlier, but we live in the now. Okay, it's like Jimmy Stewart said in the movie "It's a Wonderful Life" that we watch every Christmas. About we're living now. I need to live in a house now, Mr. Potter. I can't wait 10 years until I've got the money to buy the house. As if we're trying to figure out how to live our lives, because Christianity is an overarching philosophy. You start with God, and everything that you believe comes from there. But really, every philosophy of life is like that. We need to know what to do now. Okay, so I've given you, this is the available evidence. I believe it's the most rational conclusion.
Yeah. Well, James, I so appreciate you taking the time, and I know it was a lot to ask you to boil down 100 pages of cosmological evidence into a 90-minute discussion, but thank you for doing it for us and for me, and helping us make sense of the deep scientific and cosmological and physics involved in all this, and for helping I think bring some clarity to all of this discussion. So thanks for taking the time out of your day and joining me.
I enjoyed it. Thanks for having me.
Thank you. Absolutely. All right, and everybody listening, as we finish up again, next week is going to be the Student's Guide to Philosophy, looking at how the Christian intellectual tradition has shaped areas of philosophy. On the 29th of this month, end of the month, did the resurrection really happen? Looking at the evidence for the resurrection of Jesus. That is going to be a fun conversation. And then, as I mentioned, part 2 of this discussion, looking at the philosophical arguments for a beginning of our universe, as well as the theological implications that flow from the kalam cosmological argument, will be on May 6th. And then there's some fun conversations also happening in May. Again, we're walking through this book, so if you do want to join me in reading this massive book, I'm doing one chapter a month. And so the next chapter with Robin Collins on the design argument for our universe is going to be probably in June, since I'm gone 2 weeks in May for my doctoral studies. So with that, thank you all for being here. Thanks for everyone who is engaging in the conversation in the live chat. I so appreciate it. And hopefully we gave you something to think about, to just continue that conversation of how to make sense of Christianity in light of the scientific evidence that we have around us, and hopefully leading to better conversations among skeptics and Christians. So these things are definitely worth thinking about, and hopefully you continue to think about these things. So until next week, see you all later, and have a wonderful rest of your week, everybody. Bye.